Yeah, thank you, Joshua. Thank you for having me this evening. Yes, Jane has done a wonderful job. She has actually highlighted um, in point form what we are talking about, good agricultural practices. Let me say that good agricultural practices was actually designed to make sure that wastages and losses in agriculture are minimized, and to make sure that whatever is done in agriculture, it should be geared towards making it good for the people consuming the food, the environment, that is both aquatic life and also things like bees. So when you are practicing good agricultural practices, you are actually ensuring that you are safeguarding the environment, which is very, very important. The act of farming itself should not disrupt the environment. You should try to ensure that you fit into the environment as much as possible. Jane has given us clear in point form, and mostly I would like to run through the same and expound more on what has been said. Many people would ask, why are we interested in the soil? Why can't we just go into the farm and start farming? It's very, very important to understand that the soil, as much as it is important for crop production, it can become a source of contaminant, and it's very, very important to ensure that soil contamination is reduced. How do you reduce it? You reduce it by, especially for example, when you identify the site. Last time we talked about site selection. If you want to farm, you need to have a site. And if you follow what we talked about, site selection, then you get the site. Once you have the site, you are dealing with the soil and you have the crop that you want to grow in mind. So this site, the soil can become a contaminant if the site was a node, was used the land was used as a garage. So there could be contaminants such as like high levels of lead. You could also get high levels of heavy metals, namely mercury and other metals. So these, once you do the soil analysis, the soil analysis will be able to show you the essential nutrients and those that are not essential, which could also be which could be harmful to human health or even to livestock health in case you are growing for feed for livestock. So it's very, very important to ensure that once the site has been selected, the soil analysis has been done. Site with high levels of heavy metals should be avoided. Site with very high levels of sodium should be avoided, because sodium will also affect the crop growth. Once you've selected the soil, mainly when you talk about the soil, many people think about soil pH. Soil pH is not the major component that we check on when you're looking at the soil. You look at the soil pH, if it is low on the side of acidic, you can improve it by adding lime. And also, most importantly, you cannot design a fertilizer program if you don't have a soil analysis report. That soil analysis report will give you the content of nutrients that are in the soil in parts per million. And then the crop in question will dictate the amount of NPK, or nitrogen, phosphorus, and potassium quantities that will be required. If you look at your soil and then you see that you have some deficits, when you're designing the soil, the fertilizer program, you try and fill those deficits. For example, if K is low, you look at the K that will be required by a crop of maize if you're intending to grow maize, and then you design your soil, your fertilizer program that will be able to sufficiently provide the K that is deficient in your soil in order to support the kind of production that you're looking for. Once you do that, you are able to balance. As you balance, you also, when you're designing the fertilizer program, you push your levels a bit higher to ensure that you include some nutrients supplements for maintaining the soil. And in the same breath, Jenna said about when you use high levels of nitrogen, you might increase the vegetative nature of your crop, and to the expense of production. Let's say, for example, for tomatoes, if you have a bushy plant of tomatoes as opposed to the ideal plant, then it will have produced more leaves to the expense of fruit formation. It might even end up aborting or dropping some of the flowers. So you need to know what quantities of nitrogen that are there in your soil so that you get to know what to add, and you also have to understand what your tomato will require, how much your tomato will require, so as not to use more or use less. By so doing, you will have helped in increasing your production because you not have applied more. And then there is also a danger of applying more nitrogen to the soil because, there's various ways where nitrogen is lost through the soil, from the soil. One of them being volatilization. And so it can be leached. When it is leached, it goes to the groundwater, or it can be taken to the rivers used through soil erosion together with the soil. And then it contaminates the water. High nitrate in the water is harmful to human life, and it's not good. So it's very, very important to ensure that we understand what we need to do in our soil. Seed, I won't dwell too much on the seed because Jane touched on that. And apart from when you're using certified seeds, you do a lot of good to yourself because last time we talked about when the breeders of the seeds are breeding these seeds, they always look for desired characteristics. If for the maize, they're looking for maize that is high yielding. If you are using non-certified seeds, then you'll be shooting yourself in the arm by helping yourself to lower your yields, and I'm sure no farmer who is interested in producing less. We are always looking for producing more per unit area, and that is our mantra because land cannot be expanded. It's a fixed asset. It's diminishing because of the uses that we are subjecting it to. We can only increase our production using the appropriate or using the technology. Irrigation water, mainly why people would ask yourself, why would you analyze the water? Mainly, you don't want the water, irrigation water, when a borehole or the river may carry those contaminants, which, as I talked, we could still have heavy metals in the soil, in the water, same as the soil. I don't want to dwell on crop spacing because I talked about crop spacing last time, but I would like to talk about fertilizer application. Now, mainly, let me touch on spraying, and I'm going to expound more on this because this is the line that pushes more people towards looking for organic food, because they think that the food that we consume, once the sprays have been done, they become unsafe. I want to say this about chemicals. Good agricultural practices dictates that before you make a decision to spray, you have to do scouting to the crop. You scout your crop. When you're scouting the crop, you're looking for, how a healthy crop looks like. When you see any abnormality from the normal, that either translate into a disease. That disease could be that is caused by pathogens, or could be a physiological factor. That those diseases or defects that emanate from lack of fertilizers, and also other weather-related issues. So the moment you decide to spray, after the scouting report has shown that you really need to spray. Let's say, for example, if you are scouting for thrips, there are those thresholds that you should be looking for. If you are scouting for thrips, if you are doing a crop of snow peas, which the tolerance levels on marks on pods is very low, then your thresholds on thrips should be like less than 5%. If you see thrips that are less than 5% in a crop of snow peas, yes, you have to spray. Because if you don't, then you'll subject your crops to rejection. If, for example, you are growing onions the threshold goes up, because even if it's not very high, it's not very likely that you'll get thrip marks on onion bulb. And an onion bulb, even if it has thrip marks, then it cannot end up being rejected as the way you would have the snow peas rejected. So those thresholds differ depending on which crop you are talking about. Now, once you decide to spray, and let's say, for example, snow peas, and you are targeting thrips, you look for the most effective chemical that is allowed, that has a label recommendation for thrips. And then you look at the stage of your crop, look at the pre-harvest interval allowed in this product. If you are going to harvest before the days elapses, then you eliminate that chemical. If you'll be within the harvesting date after, if the PHI allows, then you go ahead and spray that chemical. Then you also look at the toxicological levels. If the product is in class 1, you keep it aside. If you have a class 3, you better use a class 3 more than the class 1. You can only spray class 1 or class 2 in situations whereby you do not have a class 3. A class 3 is much safer when it comes to spraying than class 2 or class 1. Once you've decided to use the chemical and you have selected the chemicals, you have eliminated all the chemicals, and you have picked on the suitable one, then you need to consider the people who are going to use the chemicals and see whether they will need the PPE or personal protective equipment, what type of PPE is required for that specific chemical. Right from the dispensing, the storeman has to have the right PPE. The person who is spraying has to have the right PPE as per the chemical or the pesticide level that you're using. Once you have the PPEs and you have decided now to go to the field to spray, you ensure that there are no people working in the field that is going to be sprayed on. After you have ensured that the spray program starts, or the spray act now starts, after spraying, you have to ensure that the workers don't go back to the harvested spray, and you put a flag, a red flag, to show that that is danger. It's a danger zone, and workers are not supposed or are not allowed into that block. Then once one day has elapsed, and especially most of the chemicals have days that they have re-entry period. There's a difference between re-entry period and pre-harvest interval. Re-entry period is the time or the number of hours that have to elapse before workers are allowed into a treated crop. Why do we have to do this? Because once you spray a crop, there are those fumes that when you're using you mix the pesticide with water. Once you spray, evaporation starts immediately, and fumes, those are fumes. You ensure that by keeping the workers away, you are protecting them from these kind of fumes. But if they go there one day after spraying, and if for the pregnant mothers or expectant mothers, they are allowed more time because of the vulnerability. So these are the things that you have to take. Now, once you do that, you also have to, in the spraying aspect, you have also to manage your resistance. So why do you manage resistance? You manage resistance because you don't want to use a certain pesticide today, and then use it next week or the other week, because pesticides have a way of fighting back, and they build resistance to these pesticides. Once you once you spray, next time you come and use the same chemical, you'll find that, or you may find that the killers will not be as effective as the first one, because those pests or the diseases will develop resistance. To avoid that, you ensure that you are alternating pesticide with different mode of action. And when I say different mode of action, we're not talking about brands here. We're not talking about brand names. we're talking about active ingredients or chemical groups. Let's say, for example, if I may give you an example, you could be using duduthirin. Duduthirin is a pyrethroid. So if you spray duduthirin this week, and next week you come with a Fastac, which is another pyrethroid, you don't have alternated the names, but it's the same class. So you need to ensure that you are using or you are spraying pesticide with different mode of action in order to manage resistance. Now, when it comes to human consumption, human beings are protected through the pesticides, through observing PHI or pre-harvest interval, the period of time that has to elapse or the number of days that have to elapse between spraying and when you harvest your crop. When you harvest your crop, it is supposed to be safe. Or it may have residues in it, but those chemical residues, depending on the observation and the scientific data available, those are the allowable residues that are supposed to be, that could be in the product before it is presented for selling. And this is where MRL comes from, maximum residue levels. And many people confuse this with minimum residue level. It's not minimum, it's maximum. Maximum allowable residues in a product for it to be considered safe for consumption. Is MRL a safety measure? No, it's not. MRL is not a safety measure. MRL is a measure which is taken or adopted to ensure that you can be able to show whether good agricultural practices took place. For example, if somebody did not follow the label when he was spraying his product, and then which leads to overdosage, the only way you can know that that person did not follow the label instructions is by analyzing the residues in that particular crop that was sprayed. If you follow the label instructions as stipulated, there is no way you would exceed the MRLs, because these MRLs are not just figures. These are set after analysis of various data and ensuring that whatever it is said or whatever MRL, for example, if you spray oxystrobin on a crop, and then with a PHI of 3 days, and then just an example, the MRL is 0.3, if you test after spraying and observing those 3 days PHI, you are not supposed to see anything in exceedance of 0.3. And this is how MRLs are followed. In short, if we spray our crops using the recommended chemicals according to the label, use the right dosage rate, observe the PHI, we will be safeguarding the person handling the chemicals from the store, the person spraying, the workers in the farm, and also the consumer. And that's why within this talk, I would want to assure people who have been shying away from picking vegetables from supermarkets that have been sprayed. Actually, those products, if you buy from those farmers who are practicing good agricultural practices, you will not be putting your health into any danger, and you'll be eating safe food. Now, what is this so much talk about chemicals? Who is the highest person? Who is the person who bears the highest risk when it comes to spraying chemicals? Is actually the storeman, or the person who is dispensing chemicals in their concentrated form. The second person in that line is the spray operator, because this is the guy who is now handling the chemicals in semi-concentrated form. The third person who is in the line of danger is the worker who is working in the field. And the last person is the consumer. If you look at the amount of chemical that is in the, I don't want to say that this is not important, but the person who carries the least harm is the consumer. All these requirements that were put in place, mainly by EU, which the EU members were very concerned because chemicals are poisonous. If you use them wrongly, you will endanger human life, environment, and everybody who comes into the line of spraying. Now, the other thing that I want to touch on is crop rotation. I want to touch this crop rotation because it's one line that is majorly misunderstood. Why do we crop rotate? We do crop rotate because we want to manage our soil. Actually, crop rotation is a way of managing the soil. One reason as to why we want to manage the soil, because we have nutrients in the soil, and then our crops, the crops that we plant, have different characteristics. So once you want to adopt, when you're doing crop rotation, you have to plant. Your crop rotation plan has to have at least more than 4 crops in a rotation sequence. These are crops which should be planted in one area within a given time. So let's say, for example, your crop is beans, and I'm saying beans because many farmers we have many French beans farmers. If your bean is your major crop, before you come to the field that had beans, you need to go through 4 crops, a minimum of 3 crops before you come back with beans. Why? Beans are attacked by you could have fusarium attacking the beans. Now, this fusarium in the soil, most of these soil pathogens are always in the soil. But they could be in levels which could not manifest as diseases once you plant the crop for the first time. For a crop to manifest or to show symptoms of a disease, the pathogens must be at a certain level, higher enough, which is called pathogenic potential, for them to cause symptoms or affect the crop. So if, for example, you start with a virgin land that had very low counts of fusarium and you plant beans, then by the time you finish that crop, the levels would be higher than where you started from. If then you plant another legume that plays host to the fusarium. Fusarium is not actually a good example because it is a host. It has a wide range of hosts. Let's talk about bacterial wilt. Let's say you have a virgin soil, you've planted your potatoes, and then you see 1 or 2 potatoes that has bacterial wilt. If you go back and plant potatoes back in the same field, the second crop will have more plants affected by bacterial wilt than you had in the first planting. So the third plant will be looking like a bushfire because you'll be fueling the bacterial wilt or the Xanthomonas in the soil. So for you to break that routine or that buildup of soil-borne diseases, you plant potatoes or tomatoes. Then the next crop should be a brassica. Brassica are not affected by bacterial wilt. The third crop should be a crop that is not a host to bacterial wilt, which should be something like beans or a root crop. A root crop because it will extract nutrients deeper than the cabbages or the brassicas. And you could, as your fourth crop, you could come with a cereal. But for the sake of this talk, a good rotation program starts with a cereal, followed by a legume. Legume because the cereals extract nutrients from deeper levels of the soil. You come with a legume. Why? Because legumes extract nutrients from the upper. They are shallow rooted. They eat from purpose qua service. And then they also add nitrogen through rhizobium bacteria. They fix nitrogen to the soil, so they enrich your soil. The third crop you come with a brassica. The fourth crop you come with a root crop, and then the fifth crop you go back to your main crop, which is cereals. So if you manage your soils like that, then you'll be able to maintain your production throughout, and you'll be able to manage your soils well, which is also a very significant aspect of good agricultural practices. Thank you very much. I would welcome questions probably at the end of the talk. Thank you. Thank you, Gabriel. Thank you, Joshua. Sorry.
Thank you, David. Wow.